Good morning, friends. Today we are going to discuss about tabulation method in digital electronics. So here we are going to solve one problem. So minimize the Boolean expression. A switching function is given. So we have to solve this problem using tabulation method. So for solving this one, the first step is we need to draw a table which contains the min-term, binary and number of ones. So we have to identify how many number of ones present in each binary numbers. So we are going to write all the min-terms given. So the min-terms given are m0, m2, m5, m6, m8, m10, m13, m14 and m15. We need to write the corresponding binary numbers for the min-terms, and we have to identify the number of ones present in each binary numbers. So we have to write here. So for example 0010 contains only one 1, so we have to write one number of ones is present. And for 1110 here 3 ones are present, so we have to write 3 number of ones are there. Now we are going to see the step 2. In step 2, so we need to group the min-terms with the number of ones present in each numbers. So we need to group these numbers. So for m0 only 0 number of ones are present, so we need to write this as a separate group. Then number of ones present is 1, we have to take this. So there are 2 min-terms are there with number of ones are 1, so we have to write this as a group. So similarly we have to find out all the min-terms for 2 number of ones, 3 number of ones and 4 number of ones. So once we have completed this table, we will move to step 3. In step 3, the procedure is we need to compare the groups. So we need to compare the adjacent groups. For example, so here m0 is there, so m0 value is 0000 and m2 value is 0010. Now we need to compare this 0000 with 0010. So if it is differ by only 1 bit, then we have to put a tick mark here and we have to write the compared value here. So we have to put a x mark in the changing value. So while comparing 0000 and 0010, the bit is only changing in the third position only. So we have to put a x mark in that third bit position. So 00x0. So similarly, so we have to write the number, the min-terms we compared here 0, 2. Here we compared m0 and m2, so we have to write this 0, 2 here. So now we need to compare the 0000, that is m0 with this m8. So this is also changing in only one position, so we have to write the change in position with an x, so x000. So then we have to write the numbers compared, min-terms compared here, so 0, 8. Similarly, then we have to compare this m2 with m5, m6, m10. Then if it is changes by only one position, we have to write this as in this group. Similarly, we have to compare all the numbers with the adjacent groups. So we will get the first level reduction here. Now after comparing this, we need to obtain the second level reduction. So second level reduction is nothing but we need to compare this group with this group. So for example, we need to choose this 0, 2 value, the 0, 2 value and compare with 2, 6. Then 0, 2 with 2, 10. Likewise, we have to compare all the values here. Okay. So while comparing 0, 2 and this 8, 10, the first bit position only changing. So here 0 is there, here 1 is there, then remaining positions are bits are same. So we have to write this value here x0, x0. So we have to write the numbers compared also here. Okay. So now we will get another 4 terms here. So in this one, in fourth step, so we have to neglect the repeating terms. So here we are getting two terms, that is x0 x0 as well as again x0 x0. So both are same, so we will take only one term here, then again here xx10, and in the next comparison also we will get xx10. So we have to cut one more thing. Okay, now we have to compare these two groups. So the bit is changing in more than one position, so there is no term in the third level reduction. So we will complete this reduction table with this table only. Then the next step is we have to find the prime implicants. So the prime implicants are the terms without tick marks are called prime implicants. So in the first level reduction there are two terms are there is three terms are there without tick mark. Okay, so this 5 comma 13, 13 comma 15 and 14 comma 15. Now in second level reduction there are two terms, so totally 5 prime implicants are there: x101, 11x1, 111x, then x0 x0, then xx10. So next we have to draw a table with all the prime implicants we obtained versus the number of minterms given in this table. So the prime implicants versus the number of minterms given in the problem. Okay, now here two numbers are there, 5 comma 13. So x101, the minterms compared are 5 comma 13. So we need to put a tick mark in 5 and 13. Likewise for all the prime implicants we have to put a tick mark here. Now let's have a look at this. So in each column, if there is only one tick is present, then put an encircle here, encircle this tick mark, and in the last line put a tick mark and encircle it. So similarly, so whatever column contains one tick mark, select that one and encircle that tick marks. Now select this single column tick mark, then the corresponding prime implicants, that is x0 x0 is present, so take this x0 x0. Then similarly select all the columns with one tick mark and write all the values here. So now we have to write the binary. So for this prime implicants, now we have to put the symbols, so letter symbols. So here in A position x is there, so there is no A term. In B position 0 is there, so we have to write this as B bar. Then in C position again x is there, so there is no C term. Then in D position 0 is there, so D bar. So similarly next one is B C bar D, again C D bar, and last one is A B C. So likewise we will solve this problem. Thank you.